Today we're on section 12.2 and it's nets and surface areas. So if I have a box, remember we were talking about surface areas before, that surface area is basically the area of the outside of the box. So if I wanted to know the surface area of this box, I could find the area of the top, the area of the bottom, the area of the sides, and the area of the ends, and just add it all up together. So basically I have drawn out, we'll say, this box. Okay, for me to do the surface area of this particular box, I would say there's two squares, okay? So this is made up of two squares, which are your end pieces. And then you also have the bottom, the top, this side, and that side, so 4 rectangles. And in this particular box that I drew up there, all the rectangles have the same size. So the two squares are 5 times 5 or 25. So when I take the 25 and I go, well, there's 25 here and 25 on the back here, if you will, the front and the back, that's going to give me 50 units squared. Then each of your rectangles is 5 times 10 or 50, but there's 4 of those, which is going to give you a total of 200. Okay, so units squared. So the total surface area of that particular box or prism is 250 units squared. The other way of doing this is to draw a net drawing. And the net drawing is basically if you cut this and laid it flat, like you decomposed the box, you would have a shape like this. Now I almost always do it this way and very rarely do it that way. It's going to be up to you which way you think is easier. So I know when I unfold this, each of these is 5. And that side there is 5. Each of these is 5. And that's 5, and this is 5. So, and then this is 10, and each of those are 10. So technically I have a rectangle here that I have 5 plus 5 plus 5 plus 5. So I have 20 times 10, which is 200. So this whole spot through here is 200. Okay? Then this is 25, and this is 25, because they're 5 times 5. So that gives me 250, which is the same as what I got that way. It just depends on which way you see it better or which way you can unfold it. Like I said, most of the time I will do it this way, just trying to picture the three-dimensional figure in what I have. So let's do another one. This is going to be a rectangular prism. Now remember, actually we'll make it a triangular prism to make it different. Triangular means the bases base are the triangles. So I have this as a base, and then that looks a little off. Let's see if we can make that better. Okay, so you see you have a triangular prism. You have a front and you have a front and back triangle. You have a bottom, you have this top side, and then you have the back side. So let's say this is 5, and let's say this is 13, and this is 10. Okay, so that's all I know right now. If this is 13 here, then this is also 13 right there. So I'm going to need my 2 triangles. These are the different parts of this particular shape. The 2 triangles, and then I have the bottom. And I'll call this thing the front. And then I have the back there. Okay, so on the triangles, I need to know this. I have the height. Remember, a triangle is 1/2 the base times the height. Well, I can use Pythagorean theorem here. 13 squared minus 25 squared So that's going to be 169 minus 25, which is going to give me 144. The square root there is 12. Hopefully you can do that out. So I know the area is 1/2 the base, which is 12, times the height, which is 5. So that's 1/2 of 60, which is going to give me an answer of 30. But I have 2 of them. So 2 times 30 is 60 units squared. Then I have the bottom. Now hopefully you can see the bottom is 12 times 10, or 120 units squared. Then I have this part right here, the front, this top. It's 10 times 13, or 130 units squared. And then I have the back, and the back is going to be 5, because the height of it is 5, and then this and this are going to be the same, so it's going to be 5 times 10, or 50 units squared. To find the total surface area, I'm going to add all these up. So these two together is going to give me 250 plus 50 more, which is 300. 360 is going to be my total surface area. So 360 units squared. If I wanted to do the net drawing on this, and I'll actually kind of do it, I probably would just cut it so that I unfold it. So I would have this, and then this, and then that, and then I have 2 triangles out from it. And my dimensions would be a 10, a 5, a 12, a 5 high, a 12, and a 13 here, and of course a 10 right there. Okay, so each of those are 10. And that would be the net drawing of that when I unfold it. So again, it just depends on whether you would rather do it all put together, or you would rather break it down and fold it down. All right, I have one for you to try, and then I'll give you your homework on this. This again is a triangular prism. Something like that. Okay. This is 6 centimeters. This is 4 centimeters. And let's see. And this is 2.5 centimeters and 2.5 centimeters. Okay, so you have 2 triangles, the front and the back. And then you're going to have the bottom. And you're going to have the front. And I'll actually put the back up here so I don't run where you can't see it on the video. All right, so let's talk about the triangles first. I have a triangle that across the bottom is 4 centimeters, and this is 2.5 centimeters. I need to know the height of this triangle, because remember I've got 1/2 the base, which is 4, times the height, which I don't know. Well, if this is 4 across, then I know that that's 2 right there. So therefore I can do Pythagorean theorem. I can go I think I did this wrong. I'm like 1.5 or 2 squared plus the height squared is equal to 2.5 squared. So let's do that. So I have 2.5 squared minus 4 is equal to 2.25, so h squared is equal to 2.25. I'm going to take the square root of that, and it's going to give me a height of 1.5. So that's 1.5 right there. So I can put that right in that. All right, so I've got 2, because it's 1/2 times 4, which is 2. 2 times 1.5, so the area of my triangle is 3, but I have 2 of them. So that's 6, and it's centimeters squared. Then I have a bottom, which is 4 times 6. So the bottom is 24 centimeters squared. And then this right here, actually the front and the back are going to be the same. They're going to be 6 times 2.5. So 6 times 2.5 is going to be 15. Oops, wait a minute, that's down here. And then that back is also 6 times 2.5 or 15. So to find the total surface area, I would add this all up. So I've got 15 plus 15, which is 30. 30 plus 24, which is 54. And 6 more is going to give me 60. So 60 centimeters squared is my total surface area. All right, this is what your homework is going to be. Not too bad. You don't have to do the net drawing unless you particularly want to do it that way. So even if the instructions say do the net drawing, you don't have to. You can just find the total surface area. All right, page 646, 15 through 23 all.